Hey everyone, thank you so much for joining us for this super exciting webinar series, the first of three hosted by Bruce Tate on API design. Bruce is always one of our favorite presenters because he clearly loves what he does and has a really rare ability to articulate that in a fun and easy to understand way. So we're really excited to have him hosting this series with us. Obviously, at the moment, with having to stay indoors, it is a great time to soak up as much of the content as is out there. And Bruce is offering some fantastic small classes where he does live coding demonstrations to help you problem solve specific issues. So I think they're really cool, and it's a great opportunity to take advantage of that at the moment. So with that, I'll hand over to Bruce, who will tell you more about that and then kick off his webinar. Thank you all.
Thanks so very much. It's always a joy to be here with Erlang Solutions. For those of you who don't know, Francesco and I go way back. He's one of my best friends on the circuit. We tend to try to visit his family when we're there, and we tend to have his family over to visit mine when they're here. So that's a great thing. So today we're here to talk about API design. And in case of any of you have followed or bought the book, Designing Elixir Systems with OTP, it's really riffing on some of the ideas there. If you think about it, API design is really about designing great software. And if you can think about every module that you write as an API and think about the users that come across it, you're going to be better off. And this is a massive topic and one that I can't completely cover. So I wanted to basically live in a couple of small areas. Now, I know that most people say that you can't measure love. I think you can. Um, if you'd like what you've heard, or even if you don't, and you want to heckle us, go ahead and give us a follow at Red Rapids or at Groxio Learning. And we really like that. That's our primary method of communication. So yeah, we'd love to have your follows. Also, I want to talk to you about, before we get going, I want to talk to you about a couple of things that are happening at Groxio Learning. For those of you who don't know, almost a year ago, I started a company to start producing content and teaching both Elixir and other languages full time. And these are some of the things that are happening. One of the things that I'm most excited about is that we have a small training that we're doing in response to the world pandemic. And the idea is that we take conference training prices, which works out to about 400 per person per day. And we put on these very tiny classes with 3 to 6 students remotely. And when we do that, we work together on a very small training. And we normally just riff on problems that are interesting to the people that are in attendance. So it's a lot of fun. So the next one that's happening is live view. So if you're interested in what happens when a web framework like the Phoenix framework meets OTP without JavaScript, it's a great opportunity. And then we'll follow that up in alternate months. We'll follow that up through the end of July. We'll follow that up with an OTP class, then another live view and another OTP. But we hope that these stay really intimate and interesting because of the small size. So the second thing that's happening is we're watching the same news channels that all of you are, and we're watching what's happening with the pandemics. So we haven't made a decision yet on Gig City Elixir, which happens in October, but there's a decent chance that we may move that online. And if we do, we want to talk about the experience. We've been thinking a lot about what we're going to bring to this overall experience. And the last thing I want to talk to you about is we do have an ongoing content publishing system. It's called Groxio. And right now, the current calendar year is about is about in our fourth segment, and each segment is 2 months long, and each of them covers a programming language. And maybe next year we'll do programming concepts or things like that. But this one is Erlang, and the next one is OTP, so it's right up your alley. And if you're subscribed when a language is released, then you get to keep it forever. And so monthly is $15. Annual subscriptions are $150, and not only do you get to keep what's released forever, you also get access to everything on the site, not just the Programmer Passport stuff. So, we have a Tetris video series. We're planning to release a live view series and some things like that. So anyway, you can check that out on at grox.io. It's only one character longer than a URL shortener. So go there and check it out. So today, I know that API design is a massive topic. So we're not going to get to it all. I just wanted to shine a little light on how I think about APIs as I am programming, both public ones and private ones, both local ones and remote ones. There's going to be a 3-part series. I've thought through the first couple of parts, and the first one is basically the wrapper around a core layer, basically library design. And the next one, we're going to talk more about process-oriented design. So an API that you might put around in your boundary layer. And the third one, I haven't really thought through fully yet, but we'll talk about making an API public and the tools that are available and the things that you might look at. But the 3 things that I'd like you to think about are first, how you layer your design when you're thinking about your users. And the second is the role of reduce. There's a small talk by a man named Melvin that talked at Lone Star Elixir, and he had this one beautiful page that he presented that he said everything is reduce. And I want to riff on that a little bit and talk about exactly why that's true. And the last idea I want to talk about, I want to give a hat tip to a man named Glenn Vanderberg, who's influential in my career and he's shaped the way that I think about software from a very early age and as a developer. But this is the idea that if you're building an abstraction around some type of library or some type of idea, one of the things that you want to do is simplify the abstraction, but also to allow a trap door so that you can reach the abstraction that's directly underneath. So I want to talk about this idea. And hopefully we'll have a chance to do some of this in a live coding setting, but I wanted to talk about a little bit about the layers and this reduce concept before we pick up the reduce discussion in the context of live code, and then work through the trapdoor problem again. So that's how we'll proceed. So I wrote a book with a man named James Gray, one of my best friends. He actually is in Oklahoma. He's in Watson, Oklahoma. But we worked together at a company called I Can Make It Better. I hired him to be my replacement. So for the first, I guess, 9 months or so, he worked for me, and then we basically flipped the script a little bit, and so I worked for him for a little while. And we wrote this book together where James provided a lot of the wisdom and I provided a lot of the voice and a lot of the organization, kind of the layering that went with the overall book. So it was just a fabulous partnership, and it's something that I'll remember for the rest of my life. So hat tip to James. A lot of these ideas are his. So thanks, James. But one of the things that was hard for us was putting together a coherent book about design and Elixir when there was so much to talk about. And one of the things that we both talked about over and over before we nailed the concept was how we actually put our applications together. And then once we started to think about that and formalize that and give names to the layers, everything became a lot more clear. So I want to start there. I want to start with the idea that we have these layers and we have a mental mnemonic do fun things with big, loud worker bees. Now, you might remember that we started this sentence with big, loud wildebeests. And then when it was time to build the cover, it turns out that O'Reilly is a business partner with the Pragmatic Bookshelf, and O'Reilly already had the wildebeest cover, so we couldn't get that. So we came out with a bee cover, and I still liked the idea of wildebeest because it was memorable. And James thankfully won this discussion, and he said, well, the cover should be about bees and beehives and cells, because that's related to what we want to do, because you think about a beehive and layers, and that's the way OTP works with these strong isolated cells within the hive. So that's how we landed where we are. So this sentence, so I'm going to give you a little bit of space to repeat after me, and I can hear you through the internet connection. So, so make sure you repeat. Do fun things, do fun things with big, loud worker bees, with big, loud worker bees. So I think that mnemonics like this are important, not because every application that we build is going to have these layers, but because it allows us a common framework to talk about the different pieces of an API design. So what do these things mean? The do fun things with big, loud worker bees? Well, they stand for data and functions and tests and boundaries and life cycles and workers. So do fun things with big, loud worker bees. And here's where the pieces live. So there's the core layer. So that's the do fun things. And that's basically the happy place in your code, the place where you can count on the integrity of the data within. This is pipe land instead of with land. And we'll talk a little bit about working with pipes. This is a place where we try to have as many reducers as we can. And I'll talk about what that means in a little while. And when we code our applications in this way, Elixir is going to reward us. And I'll talk about some of the reasons why. So the boundary, the big, loud worker bees, that's the boundaries, life cycles, and workers. These are the places where we introduce ceremony, where we introduce the necessary pieces of the application that introduce complexity and that shield the application from the real world. So the nice thing about this piece of the problem is that a lot of this can be actually extracted into applications and libraries like OTP. So some of the characteristics of this is that the data is not as predictable as it is in the core, that the functions are not as pure as they are in the core, and that things are uncertain where they are not uncertain in the core. So if you try to build a pipe through these pieces of data, since you can't manage the conditions, the pipes would break and they would lead to unreliable software. So instead of being pipe land, this is with land. So there's a structure in Elixir that allows you to build flows that deal with a little bit more uncertainty. But as you can imagine, there's a little bit more ceremony when you do. But there's one last piece that we didn't talk a lot about in the book, or we didn't actually give the name, give a proper name to, and that's the API layer. This is the piece that we're going to talk about today. This API layer is the access point, is how we present all of the other layers to the real world. If there is in fact a boundary, then this is going to react exclusively with the boundary. If this is a library, this will combine some pieces of some boundary concerns like validation, and these would wrap up the purer functions in the core. So we're going to spend a lot of time talking about this core piece right here. Okay, so we're talking about the do fun things, the core in this talk. And next time we get together, we'll talk about the big, loud worker bees. But I wanted to talk a little bit about this second idea, this idea of the importance of reducers. So we're going to try to build our software in a shape that looks something like this. So you create a new something and you transform it and you transform it. And both of those transforms take as their first argument some data type, and they return the same data type. And they might take no arguments like the ones here, or they might take 1 or 2 or even 3 additional arguments in addition to the accumulator. But these are called reducers, and I'm going to tighten up that language in just a little bit when we get into live coding. But then the last piece that you might see in places is a conversion. So we convert whatever the result is to something else, and then that can basically feed another set of transformations, right? And so this is how this is a beautiful place to live in Elixir. This is pipeland. This is the core, and it works best when we can ensure the integrity of the data in here. So this is how we're going to name the pieces. There's a constructor. I mean, I know that this is a concept that's like an object-oriented one, but think of this as the thing that builds the initial data, and it might take no arguments, it might take 1. And then there are reducers that take 0 or more additional arguments in addition to the accumulator. And then there are converters that usually just takes the 1 argument and converts to some form. So that's where we're going to, this is where things get dangerous. If you've seen a Bruce Tate talk before, there's often a part where we go off-road, and that's what we're going to do now. So I thought for this particular example, we build something like a calculator. So maybe we are maybe we're a company that makes physical calculators and we want to surround it with something like an OTP. Or maybe we're a company that instead builds something that looks like a calculator, but might have a very different presentation and user interface. So maybe it's something like a score console, where if you're scoring a soccer match, as we call it in the United States, football and the rest of the world, you would want to click a plus button or a goal button whenever the home team scores a goal, or whenever the away team scores a goal. These are basically calculator functions, and this is what we're going to start with. So we're not really talking that much about a use case yet, which is an unusual thing when we're talking about APIs, but bear with me, we're doing it just so that we can be a little bit instructional. So I'm gonna mix new calculator. This is going to create me a project, and I'm going to change over here. So let's actually blow this up a little bit. And I'm going to, pardon me while I rearrange some of the instrumentation for GoToMeeting. But I'm going to open this project. I'm going to use the Atom editor here. So, okay, so we have a calculator. And I'm going to add a couple of places, so there's already an API layer that we're going to put here. And so I'm going to say that the documentation for here is calculator API. Just understand that the module doc is a compile time variable, if you will, that specific names have specific meanings in the Elixir ecosystem. And so one of the functions that I want to have, so let's have an API. Our API is basically going to call functions that live in my core, right? And I'm not sure exactly what these are, so maybe I'll leave that as hello for now. And so let's go ahead. So if this is the API, we've got to do our work in the core. So one of the things that I could do if I wanted to, if I were working with a small component, I could say, I could just call this the core. But I already know that this is, because I've been thinking ahead a little bit, I already know that this is not going to be my core. Maybe I want to do some basic arithmetic. Okay, so this is a calculator. Calculator.arithmetic. And so let's go ahead and make some assumptions here. One of the things that I very much like to do is label concepts. So even though in Elixir I might have operators like plus and divided by and times and subtraction, I might have these operators, but one of the things that I like to do is label concepts in a way that they have a single level of abstraction and that they have a uniformity and parallelism in the way that they're exposed and they're named. So I am very much not like a lot of people that don't really care about the modules that things come from, and that they'll just consume them anyway. I realize that this is a bit of personal preference, but even if we were not building software this way, just kind of bear with me. So imagine that this calculator is not accessing functions that are just pass-throughs. So imagine that we have to build some code that actually does something more robust. And imagine that this is just an illustration. So I'm going to create a couple of reducers. So a reducer has an accumulator, it has an item, ours is going to be a number. And so in this case, it's accumulator plus a number. And I'm going to create a few of these. And so, you know what? You can imagine that those are coming along with us. And we'll go ahead and stop it here for right now. I want to riff a little bit on the concept of reduce, but to do so, I'm going to build a function. And right now I want it to say, pay no attention to the man behind the curtain. This function is going to help us illustrate a concept later, and I'm just saving a little bit of time. I'm going to call it fold, and it's going to be a list, and it's going to have an accumulator, and it's going to have a function, right? And so the reducer, I'm going to say is, let's say reducer, yeah. So this is the same thing as enum reduce. But it's going to take the function that it takes. So Elixir's reducers take an item and an accumulator. But this one is going to call our reducer. Since it's an anonymous function, I need that dot. But I'm going to put the accumulator first. And don't worry about that right now. I am just trying to provide a way to illustrate what I mean when I say the word reducer. Okay, so now we're going to say IEX mix. Okay, hope this is showing okay in GoToMeeting. And let me just bring up a list of comments. Okay, nobody's shouting at me, so I'm going to assume that expanding is okay. Oh, so I'm going to expand this thing. Okay, and I'm going to minimize this piece here. Okay, so now we're going to, so we have access to all of the reducers that we made. So I'm going to import calculator dot, and then, I don't see my did I not save that file? Let's see what happened. Okay, so let's go back to Atom, and there's my calculator, calculator.arithmetic. Okay. Yep. So import. Okay, this is our first bit to do arithmetic. This is our first chance to do a little bit of remote debugging here. Okay, so we're in webcast calculator. Let's make sure that we're in the right place. Yep, looks like we're in the right place. Calculator is there, and the accumulator is not. So I bet that I've misspelled calculator. Yep, and I have. Okay, let's try this again. Okay, so now I'm going to import. Okay, so now we're off to the races. So one of the things that I want to do is talk about the concept of reduce for those people who haven't seen it before, or to kind of clean up a little bit of sloppiness in my terminology. So I want to show three things with the reduce. The first, that reduce and pipes are inextricably linked by concept. Second, I want to show that reducers can have one argument, two arguments, or more. And the third thing that I want to show is that if you write your libraries in this way, if you write your modules in this way, Elixir will reward you, right? So let's make a list. And then let's make an accumulator. And let's play with this a little bit. So I could say add 1 to 2. I can say fold. Then there's a list. And then I could give this thing a function. So add has 2 arguments. And this is going to add up all these numbers and add them to the accumulator that we already have, right? So, or if I subtracted all those numbers, then I would have 4. Notice that this isn't really the same as enum.reduce, because basically in this situation, the arguments are reversed, so I don't get the right answer. We expect the accumulator to be first in our libraries. And in fact, if you are writing Elixir code, one of the things that you'll notice is that if you write your functions in a way that this associated type is first, you are much better off, right? So let's start to figure out why. So the first thing that I want to do is to say, I'm going to say subtract, or let's say pick off all the numbers in my list. So first, second, third equals list. And I could say in my accumulator, this is what I'm doing with reduce. So I'm going to subtract the first, and then let's do this. Okay, I've got 2 of those, we're okay. Okay, so this command right here is the same as this command right here. Oh, sorry, the fold, this command right here. So this one is what's happening there. So my content or my I'm making an assertion that subtract is a reducer. Now I want to basically expand the scope of reducers a little bit here. So I'm going to cheat, and I'm going to go with a more formal definition of reducer in computer science, right? So basically what I want to say is that I can have a function like this, and that's a reducer too. So ACC plus 1, right? And so let me show you how I'm going to kind of change the, well, how I'm going to cheat a little bit. So I'm going to take that reduce, and the function that I'm going to pass is, and the function takes an accumulator and a number. Right? I'm going to ignore the number. So I'm going to call inc on ACC. And this is going to fail because I haven't recompiled and imported again, but we'll fix that in a second. So recompile and then import everything. Okay, we're good. So now if I do this fold, yeah, so basically I started with an accumulator of 10. I started with a list of 1, 2, 3, but I really don't care what the list is, right? So the list could be anything. I'm going to get the same answers. These are just placeholders, but this is the sense that I'm using a reducer. So a reducer in this sense is something that has an accumulator of a prescribed type and returns a compatible type, right? So subtract is a reducer because it takes a number, returns a number. Add is a reducer because it takes a number, returns a number, and so on and so forth. So basically, one of the things that happens with Elixir is that since this is a functional programming language, reduce comes up over and over. So what I'll really try to do is build a reducer that serves as the core of my API. Okay, so if I look at my overall API now, here, let's go ahead. I don't want to work with the module documentation now. We'll commit this code later and leave this as an exercise for the user. So I'm going to alias. We're going to alias arithmetic, and then we're going to make these one-line reducers. I'm going to do one line because I might have quite a few of them. So I'm going to say, so add of ACC in number. This is going to be arithmetic. And let's just add a couple more of these. So this is subtract. And you might say that one of the things that we're doing is we're adding a lot of ceremony to our system. And that might be true, but eventually these two files are going to diverge because this is my API. So the job of this one, if I want to add some protection here, then basically the protection is going to, the goal of my protection here is to keep my core clean, right? So what I want to do here is say when AC is it is integer number. So I'm going to compile. Now my one-liners are going to mess with me, aren't they? Okay. So basically, this is the type of guard that makes a lot of sense to me when I am in the core layer. I'm going to add one here, and then we'll leave the fold alone because that's just for our own instruction, right? So again, the goal here is not to prevent any. We're not trying to guard against any user validation. We're trying to keep this area in the functions proper pure. And that means that everything that we're trying to do is to keep bad data out. So any type of guard that we can have, or there's another great framework, Chris Keithley's framework called Norm, N-O-R-M. It's a fabulous framework that can add some preconditions right outside of the core right here. Makes all the sense in the world. And so in here, the goal is a little bit different. So this is where if I'm taking user input, this might be the place that I access my validators. So I might import another validation library here, or add another validator within the lib directory. But the idea is that this calculator will take advantage of that validation library at this point, right? Much like Ecto has the concept of a change set, and if everything is okay, the usage model of that library is that everything goes through a change set, because we don't care as much about ceremony. We're much more focused on making sure that data has good integrity. Okay, so that's the concept of reducer. And we're going to see reducers in a lot of places in Elixir APIs. I mentioned Ecto. You don't see a lot of reducers in the Ecto framework proper. But what you do see is that we might have an expression like this. We might have repo.first, and then or repo.one, and then you might have a query, and then this query itself, this is the place where you would have some reducers, right? So there's a reducer style library, and there's a key value library that I can use to compose my queries with reducer style. And Jose actually is really good at doing this, right? So another example is in the plug. So in the plug library, there's something called a connection. So I'll build a new connection from endpoint somehow, right? And I can pipe that to functions. And each one of these things does a tiny job and modifies the plug connection, right? So it's a reducer because that thing takes a plug, it returns a plug, and whether this is a redirect or a render, this is going to change the plug.con in some way, right? So the idea of reducers is powerful in Elixir. So one of the things that I said that I wanted to talk about is this idea that we could have something called a trapdoor. And these are really important in APIs because a trapdoor allows you to simplify an underlying abstraction. And by simplifying the underlying abstraction, you could save your users a lot of ceremony. But the problem is that sometimes we often need the abstraction that's underneath, or something more powerful than our simple abstraction makes. So the idea is that you can allow access to the API underneath. And Ecto does this very well by allowing fragments of queries. And so that's a great example of a trapdoor. Okay, so in our calculator, a great way to do a, oh, we also have one more, don't we? We have def inc, and this takes an accumulator, and this calls arithmetic.inc. Increments the accumulator, right? So this API is going to change a little bit if we decide to change the abstraction, right? So for example, or if we decide to add some ceremony on the outside. So for example, if this API were for gen servers, in the next couple of weeks, we'll talk about what the needs of that API might be. So let's say that we're building a programming API, and so we really feel pretty confident that if there's an error here, that it's actually a programming bug, and that this code is going to capture any kind of problems that I have related to my calculator, right? But one of the things that we're not as confident about is that add and subtract is all that our customers will ever need. So we think that that'll probably catch like 90% of the cases, but maybe we want to provide a trapdoor. So let's provide a function called custom. Okay, so def custom. Let's go ahead and add that down here. This takes an accumulator, a number, and some function. And this is going to say, we're just going to call the function. Okay, so now we have a trapdoor, right? And so we can have the same type of guard that we have elsewhere. So let's go here. All this is going to do is pass through, right? This is going to do arithmetic dot custom, and then we're going to call that with ACC number and F. Okay, so one of the things that I'd like to do before we wrap up is look at this idea of the trapdoor. So what we have now is interesting, and I like this custom one a little bit, but maybe what I'd like to see instead, maybe I'd rather see a usage model that says something like this. Maybe it creates a custom calculator and everything in there is custom, right? And if everything in there is custom, then probably the reducer that I'm going to build is the builder of the calculator itself, right? So so that we actually have something like this. Maybe we have a new file. So def module and maybe what I'm dealing with here is a struct, right? So this is going to be a structure. This is going to be a calculator that has functions. And these are going to be in a map, right? And where the keys are, and the operators are kernel plus, right? So this abstraction might allow me to have something, might shift my API quite a bit, right? So rather than an API that sits like this, I might have an API that looks like this. And I might have another one that looks like this. And maybe that's as far as we want to take it. And this might be something like this, right? But maybe this is as far as we want to take it, because maybe if we're building calculators, this is probably enough. So if that's the case, if we can see, so if we look into the future as we're building our API, and we haven't really quite built in our capability to customize, but we can see that that might be happening sometime in the future, my API design might change. I might have something like this: add, do, right? Accumulator number. And this is subtract. Right, and maybe let's, that line is getting a little bit long. So maybe we do something like this, right? So this API design is based on the goal of someday allowing customization through a design that uses a builder, right? So the thought process that I went through to get to this API for a calculator is that someday I'm going to want to implement a trapdoor, and someday these two, the implementation of this is going to look much more like I take a calculator, I extract the function, and then I call the function based on these numbers right here. And so those are some of the ideas that I want you to think about when you're designing APIs. I think that this is probably a good place for us to wrap up and take a few questions. But before I do so, let me wrap up here first and remind you of a couple of things. First, I want to say thanks to James Gray, who wrote this book with me. He's a brilliant man. He's a great engineer. You should support him whenever you can. So the second thing is that I am at Red Rapids. I'd love to see your follow if these ideas are interesting to you. I'd love to see your follows, and I'd love to communicate with you. Let me know what you thought as we go. So the third is we have some things going at Groxio Learning. We have the small trainings. These are really a lot of fun. You get to do this with me and a couple of other small students. I usually spend about 25% of my time on the keyboard. The rest of the time it's a student. And so watch Twitter for our conference news. Gosh, we're not quite ready to move Gig City Elixir, but almost. In Lone Star Elixir, we just don't know what's happening there yet. And the third is that go to grox.io for a subscription. If that's interesting to you, we've got monthlies for 15, annuals for 150 a year. They're really priced for the world market. It's a ton of content. It's just over a half book for each one. It's 4 to 8 videos for each class that we turn on. And if you get Elixir now, if you subscribe now, you'll get the full Elixir chapter for $15. And if you wait till past the last release, then you'll only be able to buy it a la carte, which is going to cost you $70. So, any questions?
Hey, Bruce, thanks again for that. That's awesome. Let's get to some questions. The first one we had come through was, can you go over the difference between fold and reduce again? I'm not quite getting the difference.
Between fold and reduce. Okay. So basically basically what happens is fold is a reducer where the accumulator comes first, right? So if I am writing my API explicitly for fold, then everything is going to look like this, right? And in fact, Elixir wants me to write my functions in this way because if I have my accumulator first, things pipe well, right? And in fact, if I do some things like for example, if I take the number 5 in IEX and I type I for information, I see that this thing is an integer, right? I see the module that it works with is integer, and I know that most of the functions on integer will take the integer as the first argument, right? So Elixir wants me to design things this way. But if I say h enum.reduce, which is, remember, fold, exactly like fold, it takes a function with X and an accumulator, right? X comes first, the item comes first, the accumulator comes second, right? So why did Jose build the language this way? Well, it just turns out that he built enum reduce as part of the core library before pipes became important and so relevant in the language. So that's it.
Perfect. Another question we have is, what do we gain from norm that we cannot get with specs? What would you think are the biggest trade-offs?
Yeah, so norm basically allows me to write some code to check preconditions. And so I think that I'm not going to talk anybody out of type specs. There's already, I mean, there's so much power in building the specification. What I might be able to talk you out of, though, is the idea that in a dynamic language like Elixir, specs might specs don't how do I say this diplomatically? So the spec tooling might lie to me, right? So specs aren't enforced with the rest of the language. So I think that that the trade-off is that norm. So there's two trade-offs. One, norm can allow you validation of types with code. And second, you're not just validating the types, right? You can actually add additional validations so that maybe you can look at maybe if you've got an invoice, you can make sure that that invoice is not canceled in the specification. So anyway, norm is not heavily used, but I love the idea that we might check preconditions. That idea is actually a classic one in communications that or in computer science that comes from languages like Ada.
Cool, perfect. And then the last question I think we'll have time for today is, I think, a nice one, which is, can you remind people of your Twitter name?
My Twitter name is Red Rapids, REDRAPIDS, and this is a cool story. When my first company was actually built for Ruby, for building quickly developing Ruby applications, but I'm also a kayaker, and my favorite kayak was Prion, and it was this thing that would let me bomb down big creeks with having a lot less skill level than most people that were on the same creeks. I mean, that thing would it would never get stuck in any hydraulic or anything like that, but it was kind of like going down a tiny creek in a barge. So anyway, people made fun of me with they called it the big red barge. So Red Rapids kind of came out of that.
Perfect. Okay.
And I have time if you guys do to take more questions if there are more out there.
Cool. Yeah, we did have a couple more come through, so we'll get through them and then we'll wrap up because there were a couple coming through as we got your Twitter name. So our next one was, how does do fun things with big loud worker bee compare with Phoenix context?
Okay, so that's a great question. We actually talk about Phoenix context in the designing Elixir systems with OTP. So basically, there's idea of an application that's a little bit ambiguous in the Erlang ecosystem. So let's talk about the concept of a component. Let's say that a component is something with its own boundary, its own lifecycle, its own API. And so there are four dependency styles that are sanctioned in the Elixir ecosystem. The first one is that I can create here in mix.exs, I can create a dependency, and the dependency might be a get dependency or it might be a hex PM dependency, these two, right? So the next one is that I might have a dependency that's a path dependency. So for example, if I wanted to have a sub project called a sub calculator, I could say mix new sub like that. This thing is called a Poncho dependency, and it got that name for, I guess, not quite an umbrella or something. But this is very popular in Nerves applications of things. So the third strategy that you could use to build, to build, to use with the two fun things, basically this is a component philosophy. The third strategy that you could use is to build an umbrella application, and that's basically a structured way where Elixir kind of helps you manage and check dependencies, and actually helps you resolve some of the ceremonies in dealing with multiple applications. And that's so you could do things like run tests for your whole for everything in your ecosystem. That's called umbrella dependencies. And the fourth one is Phoenix context. And Phoenix context. So each one of these things has starting from the get dependencies. Each one has a greater degree of separation, but a higher degree of ceremony when you're working with multiple applications that are bound, that are coupled more closely together. So you get to decide how much coupling that you want. I work with all four, or actually three of the four. I don't use a lot of umbrellas, but I use the other three quite extensively.
Cool. So the next question is, what are the trade-offs of having guards or norm data checks in the API layer instead of the core?
So basically I think that guards versus the norm data checks. So basically I'm gonna change the question a little bit. I think that you have that each piece, each layer of the ecosystem has a different requirement, right? So let's see, let's start right here. Right, so remember these were data functions test with boundaries, life cycles, workers. So basically there's an API layer that wraps this whole thing, right? And there's an API layer that is on top of the two fat rectangles, if in the case of a library, right? And so the places, so basically I protect my core with something like guards, and Norm can actually offer me a different type of protection, and gives me more of a granular way of controlling the preconditions. I'm basically trying to keep everything in my core pure, right? So there's another set of concerns that I have on my boundary layer, right? So those concerns are more related to the validation of data, and specifying and cleaning up error messages, and deciding which error messages are that we need to express as data, which need to be exceptions, and what those error messages are likely to say. And we'll talk about some of those issues next week.
Perfect.
Or in 2 weeks when we do the next one.
Perfect. And then one last question for this session. Is trapdoor a way of creating a generic function?
Basically, so for a calculator, a generic function, the generic function is the abstraction beneath the one that we're working at, right? So basically, a trapdoor is a way of exposing the next layer of abstraction down. A good example is with Ecto. You might have some features that are wrapped up nicely in the Ecto API, like an aggregation based on counts. But there might be additional features that are only supported by certain databases or certain database libraries. Like, for example, there are different strategies for managing tree tree-based data, right? Like there's a hierarchical way of managing tree-based data that kind of looks like an IP address. And we might open up the abstraction beneath that by using ectofragments, which basically allows me to pass um, to say, okay, most of this API is written in high-level Elixir, but this tiny bit, I want you to take all the training wheels off and pass this directly down to the database layer underneath.
Perfect. All right, I think we'll wrap up there. Thank you again so much, Bruce. Thank you everyone for joining us. Just a reminder that in a fortnight, at the same time as we started tonight, on May 6th, we'll have the next one. In the meantime, we're going to email you a recording of this session. So if there's anything you want to refresh upon, or if there's anything that you'd like to ask us in next week's session based on this, give that a look. We will also include links to Bruce's training that he's mentioned earlier, and some other stuff from us. One last thing, if you're free and available tomorrow evening, we have the virtual Beam users group meetup. This was the London meetup, but obviously since we've moved online, we've been able to open it up to attendees from all around the world. So if you'd like to join us tomorrow from 6 p.m. British time, GMT, you can Google Virtual Beam Users Meetup and get the links and details there. Thank you so much, and I'll see you all in a fortnight.
Many thanks, everyone.
Bye.